Okay, so we're going to translate figures in a coordinate plane. So we're going to be moving some graphs, essentially. So first, you need to know what a transformation is. So a transformation is a change to an object. Okay, specifically, today that transformation that we're looking at is a translation. So translation is sliding an object. Okay, so an image is the picture after a transformation. Okay, and then a tessellation is a pattern created by repeating shapes. Okay? So we have transformation, which is a change to an object. So specifically today then, we're going to be looking at translation, which is sliding of an object. Okay, the image is what you end up with after you've transformed something. And then tessellation is a pattern created by repeating shapes. All right, so example 1. For the diagram shown, describe the translation in words. Okay, so if you notice, we have regular A here. And up here we have A with an apostrophe. Now that apostrophe really means A prime. Okay, that's how we say it. So go ahead and write that down. A apostrophe really means A prime. And what that tells me is this right here, this is my image. This is my image. Okay, so that's after the transformation. So that means we're going from this picture to that picture. Okay? So, to describe it in words, we're going to think of moving horizontally and vertically from one of the points on the original figure to the matching point on the other figure. So if you see they have a dot right here, so we're going to talk about these two dots. So, from the first thing, I'm going to say, I'm going to count up because for me, or I'm going to count over because, right, we usually count over first. So from here to here, I'm going to count 1, 2, 3, 4. So I moved 4 units to the right. Okay. I also then had to move 1, 2, 3, 4, 5 units up to go from negative 3, 2 right here to positive 1, 3. Okay, and yeah, we picked those points, but if you counted from any matching points, you would have had to move 4 units to the right and 5 units up. Okay, so it doesn't really matter which point you pick for the counting piece. Now, of course, writing this out in words all the time would be super obnoxious, and mathematicians, like I told you before, are fairly lazy. So they came up with a shorthand. It's called coordinate notation. Okay? Essentially, it's going to always look like this, except I want you to put that this is a plus or a minus, and this is a plus or a minus. It could be either, depending on which way we're shifting. Okay, A indicates how many units a point moves horizontally, or across the x-axis, and B indicates how many units a point moves vertically. Okay, so we're going to move the point xy to the right if A is positive, and to the left if A is negative, right? Just look at the numbers. If you're going to the left, the numbers go negative. Okay, move the point up if B is positive, And then we're going to move it down if b is negative. And again, guys, if you can't just remember that, just look at the number lines, right? As you go to the right and up, it's positive numbers. As you go to the left and down, it's negative numbers. All right, so let's try one here. Example 2. Draw triangle ABC with those vertices. All right, well, that's easy enough, right? We just plot those points. So negative 2, 1, so this is A. Then negative, so this is A. B would be negative 1, 4. So this is B. C is 0, 1. So that's C. So there's that triangle. Done. Then find the coordinates of the vertices of the image after the translation, x plus 4, y minus 5, and draw the image. Okay? So all we have to do is plug into this formula. So first I drew it. Then to translate triangle ABC, I'm going to add 4 to the x coordinate and subtract 5 from the y coordinate, because that's what it says in our rule right here. Right? I didn't just make those numbers up, it comes from that rule. So if I add 4 to the x-axis, so I have negative 2 plus 4 would be positive 2, and then 1 minus 5 is negative 4. Right? Repeat with B. Negative 1 plus 4 is 3. 4 minus 5 is negative 1. Okay, 0 plus 4 is 4. 1 minus 5 is negative 4. Okay, so then now we have all our new points, so now I can draw it. So I'm going to put A prime at 2, negative 4. So this is A prime. Oop, doesn't like me drawing that dot there. A prime. Then B prime is going to be at 3, negative 1. That's B prime. And then C prime is going to be at 4, negative 4. C prime. Connect those dots. So there's my image, right? Notice that each point on my original triangle moved, right? Let's just go count C. 1, 2, 3, 4 units to the right. And 1, 2, 3, 4, 5 units down, right? And again, that should match this rule way up here, right? Plus 4 means 4 to the right, minus 5 means 5 down, so it works out. All right? You should always end up with a picture or an image that matches your original. They should look the same. If you started with a triangle, you need to end with a triangle, right? That look the same. Okay, let's try the checkpoint here. So, checkpoint. Draw the quadrilateral PQRS with those vertices. Then find the coordinates of the image after the translation and draw the image. Now, I am going to pause the video here because I want you to work through this on your own first. And then on the right-hand side, let's just have you enter the new points. Okay, so like P prime will be this, Q prime will be this, and R prime will be this, and S prime will be this, right? So let's just have you enter the coordinates on the right, and then once you have that done, you go ahead and hit continue, and you can check your graph on the video. All right, so first I'm going to graph the original. So negative 4, 1, that's P. Negative 1, 0, that's Q. Negative 2, negative 3, that's R. And then negative 4 would be S. So there's that, right? It's kind of a, I don't know what it is. It's quadrilateral. All right, then I'm going to add 6 to my X's and add 5 to my Y's. So if I add 6 to my X's, P is going to go to 2, and 5 to my Y, so 5 minus 1 would be 4. Q, 6 minus 1 would be 5. 0 plus 5 is 5. Okay, R, negative 2 plus 6 is 4. Negative 3 plus 5 is 2. S, negative 4 plus 6 is 2. And Y, negative 4 plus 5 is 1. So then I plot those points on my picture here, and I'm going to go ahead, or on my graph, and I'm going to change colors so it's easier to see. So P is going to be at 2, 4. P prime. Q prime is at 5, 5. So we're right on the edge of my graph here. R prime is at 4, 2. And then S prime is at 2, 1. So I didn't do something right. Because those should match. So what did I not graph right, guys? 1, 0, negative 4. Oh, I didn't graph the original right. Let's try this again. P should be at negative 4, negative 1, so that goes there. So that should be P. Now does everything line up? Nope, R and S are still messed up. So let's see, what did I do wrong? Oh, I graphed S wrong. Good. I'm just making all sorts of silly mistakes. So S is at negative 4, 4, so that should be down here. There we go. Now it looks right. All right, hopefully you got that. Any questions, make sure you're asking Ms. B. All right, let's go ahead and look at the example 3 then. Creating tessellations. So tell whether you can create a tessellation using only translations. Okay, so only sliding it could I create a tessellation. If you can, create a tessellation. If not, explain why not. So a tessellation has no overlaps and no gaps. So here for A, I would say you cannot translate a regular octagon to create a tessellation. Notice in the design that there are gaps and overlaps, right? There's a big gap here, and there's an overlap here, which is not what you want in a tessellation. Over here with my rectangle, I absolutely can translate the rectangle to create a tessellation. Notice in this design down here, right, that there are no gaps or overlaps, which is what you want with a tessellation. All right. If you have any questions or issues with tessellations, you can be asking Ms. B, you can ask Mrs. Schmidt, you can ask Mr. Torres tomorrow, or you can track me down on Thursday when I'm here. Otherwise, I hope you guys have a great rest of your day. That does finish us up for 12.4. See you later.